Hey everybody, we're going to talk about arrays and tables. Some of this will be review, but we want to, take a look at some of the things that we've been looking at. And as I've told you repeatedly, table methods are very important in the class. Why? Because we get all of our data in tables and we need to know how to work with them. And it turns out that the columns of a table are arrays, and so they're connected, and we can do arithmetic on the arrays. Okay, so let me get rid of these. Okay, so make sure that we run the initial code here. And we're going to review the key five table methods, right? And again, dot sort, dot select, dot show, dot where. We use them all the time. Now, dot column is the way that we retrieve the column of a table and turn it into an array. And we're going to show that one in just a second, but let's start with the others. And we're going to start with a review of dot where. Okay? So we've got some questions like display the skyscrapers table with only columns name and height. And okay, so skyscrapers has been uploaded here, or uploaded into our notebook here. And what am I going to do? I don't want to type the word skyscrapers, so I'm gonna delete this and just call it sky. I'm gonna rerun that. So now the name of my table will be sky. Okay, and I want to find a skyscrapers table with only the columns name and height. Okay, so sky.select, right? Sky.select, it will allow me to just get name and height. But remember, those column titles are text, so I need to put them in quotes. And now I have the height of the skyscrapers, and you can see One World Trade Center and Willis Tower, and the height in meters. Okay, so we did select, that's a review, but use dot drop instead of dot select. Well, I'm gonna have to go sky to show some of the tables. Let me do sky show three. I'll show 3 rows of the table. Why? I need to know what to drop. So if I'm just going to have name and height left, I need to drop material, city, and completed. Okay, so, and I'm going to leave the dot show there for just a second. I'm going to do the dot drop. Why? Because I need to drop material, I need to drop city, and I need to drop completed. And I left the dot show there so I could see what it was that I needed to drop. So sky dot drop material, and do I get the exact same thing I saw up here with the name and height columns? Yes, name and height. So remember, dot select, I tell it which columns I'd like to see. I name the columns I want to see. Dot drop, I name the columns that I don't want to see, that I want to not be displayed. All right. Find all the Chicago skyscrapers. Okay, so I can do sky dot where. And I want it to look, I want the where function to look in the city column. What I want it to look for, I want it to look for the word Chicago. Okay? Now, and this has frustrated some students that it does the assignment, Chicago equals, it assigned the table to this variable named Chicago, right? But I can't see what's in it. So I'm gonna do Chicago, let's say show 7. And you can see that, yeah, it looks like it's working. I mean, there are 29 rows omitted, and we haven't looked at every single row, but in the rows we can see the city, in fact, is Chicago, right? So we're reasonably satisfied that this has worked, okay? And display the newest 5 Chicago skyscrapers. Okay, well, I can start with the Chicago table. Created the Chicago table right up here. Well, actually, right there. So I can use the Chicago table, and what do I want to do? Display the newest 5. Well, what if I sort? Okay, so I can do Chicago dot sort, and I want to sort based on the completed. And again, it does the assignment, but it won't show me that unless I type in the variable name and say New Chicago. Again, I'm just going to do show 3. Why? Because I want to see how it's sorting. And oh, these are the oldest 1965, 1968, 1969. All right. So what does that mean? That means that I want to reverse the sort. And remember, we can reverse the sort by adding a descending equals true option to the sort. And now this will be the newest, right? But it says display the newest 5. Okay, well, instead of show 3, I changed that to a show 5. Boom. Okay, so the most recently completed skyscrapers, you can see right here. Okay, so that's just a review of some of the basic um, table methods that we use all the time. So we're going to jump into the lesson for today, and we're going to learn about a great little function called make array. Make underscore array, which does exactly what it sounds like it would do. It creates an array function. Excuse me, it creates an array when I put values into that function, right? So my array equals make array 1, 2, 3, 4. It makes an array with the values 1, 2, 3, and 4. And here's an array we're going to call another. And the another array has 60, 70, 80, and 90. So again, we're just seeing that make underscore array works to create arrays. And we use this sometimes, right? It depends. Sometimes we use it outside a table to add a column to a table. You know, there are different things we can do. But we often find it useful to be able to create whatever array we need. And then it says practice question, multiply my array by 2. Well, okay, so my underscore array times 2. And you'll notice that it distributes the 2 to all 4 values in the array, right? So individually, each element gets multiplied by 2. And then it says raise my array to the second power. Okay, so my underscore array. Remember, sorry, array. Remember, exponents are displayed by a double asterisk. And again, it's applied this to each individual element. The 1, the 2, the 3, and the 4 become a 1, a 4, a 9, and a 16. Okay, and then add 1 to my array. Okay, my array plus 1. And what's going to happen here? Well, the 1, 2, 3, and 4, they're all going to get your 1 added to them, so it's going to be 2, 3, 4, 5. Ah, and there we go, 2, 3, 4, 5. And then the practice question, can we add two arrays? Well, let's try it. My array plus another. And it did. It took the 60, 70, and 80 and added it to the 1, 2, 3, 4. And you can see that it's adding the first element of my array to the first element of another, and the second element to the second element, and so on. But because it's matching up and doing this element by element, it means that the arrays must have the same number of elements, or we cannot add them. Same thing, we can't multiply them, we can't subtract them. It will do it element by element if the arrays that we're working with have the same number of elements. Okay, so we do this sometimes because it speeds up the arithmetic that we need to do. And we're going to practice using a few a few functions on these arrays. And notice how we take the sum of my array divided by the length of my array, which, if you think about it, is the average, right? The sum of the elements in the array divided by the number of elements in the array. So the average of my array should be 2.5, and it says here to find the average of my array, okay, and it specifies mp.average of my underscore array. Okay, and did we get the same thing? Well, let's print out the average. Oh wow, we got exactly the same thing. Okay, also notice that np.mean works exactly like np.average. It doesn't matter which one you use. They both will give exactly the same answer when we put the exact same data in them. And now they give us a data set n. And these are recent, for a recent November, they're the daily high temperatures in Dahlonega, Georgia. Okay, so let's run this cell to enter the data into this variable n. And how do I find the average of n? Well, let's do np dot mean of capital N. And let me type in an average below it so I can see. So the average temperature in November, in this recent November in Dahlonega, the average temperature was around 61, 62 degrees. So it was a rather pleasant November. It hadn't gotten really cold yet. Standard deviation, okay. So notice that we'll do stats dot TSTD, and this will produce the standard deviation. A couple of things. First of all, we've printed it out. Second of all, please notice that the MP, remember, the MP is an alias for NumPy, numeric Python, which does look a whole lot like the word numpy, but this is an alias and it activates this package so that we can use the average function, which is great. I think you guys remember that from before in class. Well, this is the stats package where from scipy.stats. Okay, so what I'm saying is scipy dot stats. Okay, so what is it? Well, it's a package within a package. Scientific Python, SciPy, has different packages, and the one that we want to use, of course, is the statistics package. So this stats is an alias for scipy.stats and has access to everything that we need in terms of these statistical functions. The specific one we're using is standard deviation, and this is STD. Why? Well, it turns out there are two ways to calculate the standard deviation, for the population standard deviation and for the sample standard deviation. And we always use the sample standard deviation, which is this one. Okay. We'll talk a little bit more about the differences at another time. Sample size, what we do to find sample size, right, is len. Oh, and I didn't take the dot, dot, dot out. Okay, so let me put that in. And you can see sample size is 30. Okay, so we've got the standard descriptives. Standard descriptives, the mean, the standard deviation, and the sample size, they're right here and you can see them. And we have the 5-number summaries, which is the minimum, the 25th percentile, the median, which by the way is the 50th percentile. We have the 75th percentile and we have the max, okay? And so we can do the same thing. We can find these values. How do we find them? Well, the minimum is just the minimum function, right? So min n. And again, if I type the variable name on a line by itself, oh, I named it min, but min is a keyword. So let me go minimum. Python is getting confused because if I use a function name as a variable, it doesn't want it. And why are we messing this up? Me back up. Okay, and I believe I've kind of messed up this notebook. Why? Because I used min as a variable and it didn't like it. So I'm going to use maximum down here. Why? Because it works. Max n, right? And it's not freaking out and giving me a error code. But because I used min earlier as a variable, this notebook is confused. All right. So this one, I'll just hashtag it for a second. to get rid of the error code. Why? Well, because this will work if I hadn't have been a bonehead earlier, right? So in Q1, MP dot percentile. So I can say, hey, go into the N array and give me the 25th percentile. And then if I type in Q1, there you go. The 25th percentile temperature for November is 58 degrees, approximately 58 degrees. The median is easy. It's just mp.median. And I hope I haven't messed this up. It doesn't mess up here. Why? Because median is within the mp.median, so I don't get the same conflict that I got up here. Okay, Q3, that's mp dot percentile again for n, comma, and 75 to get the 75th percentile. Q3 to get the variable showing its value, right? And by the way, I can do mp dot percentile n, and if I put in a list, that means square brackets, I can get the 0th percentile, the 25th, the 50th, the 75th, and the 100th percentile. And I have to close the parentheses. And when I do that, I get the 5-number summary printing out using percentiles, using the 0th percentile to get the minimum, the 100th percentile to get the maximum, and the 50th percentile to get the median. So this is a way to get the 5-number summary. Um, Again, the median isn't exactly the 50th percentile, so this won't always work to get the exact numbers we need, but it'll always get us in the ballpark, okay? So this is just kind of extra. They didn't ask us to do this, so I'll delete it out, but those are the way, those are the ways that we get the 5-number summary. All right, now, columns of table are arrays, and I said at the beginning of this video that we would use the dot column function to extract a column from a table. Okay, and by the way, we have a way to show part of a column, just like the dot show 7 or dot show 5 will show the first few rows of a table. This square brackets :5 will show the first 5 elements of an array. All right, so we've got some new tools to work with. Let's see how they work. And first, they import the skyscrapers column, but remember we changed the name of the skyscrapers column table to sky. So as long as I have a sky, this actually pulls all the height column out and shows it to me. And these are just the first 10 entries because of that :10 that I've added. It will show them all to me if I delete that, right? It'll show me all the heights, but there's a bunch of them. And all I wanted to do was show you that they're there, that the whole column heights has been pulled out. All 200 numbers are there. And when I do dot column, right, I end up with an array with all 200 values in it. Now, first thing they're asking for is an SF table. So I want the skyscrapers that are in San Francisco. Okay, so sky.where, and I can do the city, comma, is San Francisco. And I'm going to do sf.show5 because I want to make sure that I am getting the city name of San Francisco, which it appears that I am. Again, oh wait, and we don't have any. There are only 4 skyscrapers in this table from San Francisco. Right, so we're actually seeing them all. I didn't need the show 5 to limit the table because the table's small. All right, then create the San Francisco Heights array. Okay, well, how do I do that? I take the SF table and I do dot column. And height is the name of that column, so SF heights comes out. And if we want to see what we have, we should have an array, not a table now, because we use dot column, and there you go. There are the 4 heights of the 4 skyscrapers in San Francisco, and you can see 260, 237.44. Right, so it is. It's going into this column, into the height column, which we specified here. and it takes the whole column out and turns it into an array for us. All right. So they ask us to do this for the New York skyscrapers and then to find the heights of the New York skyscrapers. So let's do it. Sky dot where city, comma, New York City. Okay, then I'm going to print out, and I know there's a lot of these, so I'm going to do a show 5 because I think there's 70 some skyscrapers in New York City in this table. So if I only show 5, we see that I am getting the city to be New York City. I'm going to do the same thing that I did up here, right? I'm going to use dot column to get the height column from the New York skyscraper. So I have ny dot column height. And I'm copy pasting my heights down there so it will show me um, what's going on. And I did my column instead of ny column. Did you see that I had an M instead of an N? It will do it. And it prints out all of these numbers. Again, I can use the square brackets, :7 to just show the first 7 values. So I am getting the right values. You can see the 541 matches up to the 541, the 425.5 matches up, right? So it's taking that height column out and it is making the correct array. And I get to do it one more time for the LA skyscrapers. So I've got sky.where the city is Los Angeles. And there are 11 skyscrapers in Los Angeles. The 10 that they show plus 1 that got omitted, and that's fine. I'm going to do a show 5 just to limit how big this notebook grows. All right, then LA Heights, I do the same thing. I take the LA table and I go dot column height. And I can print all of these out. This will be fine. There's 11 of them, so I get 11 values in my array. Okay, so we're learning how to use dot column, and we get these arrays, and we have these array names. And then they say, okay, suppose we wish to add a column to the San Francisco table. The heights are in meters, okay, and the conversion is that we need is that there's 3.28 feet per meter. So we want to convert all of the San Francisco heights to a an array, and then we're going to start working on the array. So let me actually, I've added a couple of rows. I'm going to put this down here. Why? The first thing I'm going to do, right, is I'm going to use the SF heights table that I created up here. I'm swinging back up to see, okay, yeah, I have SF heights, which is an array. Okay, so let's go SF heights. Let's just show that for a second. Right, SF heights, boom, okay. Now, if I need to use this conversion factor of every meter, every one of these meters, let's say in the 261, right? There's 3.28 feet in every one of those meters. So what do? I want to multiply the array by 3.28. Okay. Okay, so there we go. Now we have the San Francisco heights as feet. Okay. And we're going to add down below. So let me copy paste this up here. All right, so SF heights in feet is actually just this. I didn't really need to open this up. Let's just run that. You can see what we have. I've selected the whole cell and I'm hitting DD. Select the whole cell, hit DD, that deletes. I'm hitting save now because if we start deleting things willy-nilly, I might need a saved copy of this thing, so I'm saving. Then to add it to a column, look what it says. It says to uncomment, okay? So this is going to be a show and tell. They're going to display for us how to use dot with column, which is a table method, to add a column to a table. Interesting. But they say, hey, just uncomment the stuff below. Well, to uncomment, I just take the hashtag off. The first symbol of every line is a hashtag. I delete those hashtags, and notice I'm doing the SF dot with column. So the table San Francisco with column. And this is going to be the title of the column. And this is going to be the array data that goes in the column. Okay, and to compare it to the old table, you can see what happened. The first few rows of this table, right, are exactly the same as before, but it's created a column with this title, and something is awkward here. Let me go back up and see what I did. Because I've got everything working except I just have a bunch of 3.28, which it would appear that I got something wrong. All right. So SF heights feet should have been this. Okay. This is interesting. Okay. Um, let's try this. What if I do the arithmetic inside here? There we go. I don't know why it was having trouble pulling that value in, but notice when I take the heights in meters times 3.28, it does the arithmetic, converts all the heights, and I get another row added. What's the key feature here? The key feature is this dot with column allows me to add a new column, and I go with the title of that new column first, and then the array data that fills up that column goes in second. Okay, so we're almost done here. They have some practice questions. Find the difference in heights between New York and Los Angeles skyscrapers. Okay, the difference is NY heights minus LA heights. And the problem is that they're different sizes, right? There's 11 skyscrapers in LA in this table and 73. So it can't subtract the heights, but it says find the difference in the average height. So let me do np dot mean of the NY heights minus the np dot mean of the LA heights. And let's see if that'll fix it. Yay, it did. Well, it's not throwing an error. Let's see if it calculated it. Oh, and there's about a 5.3-meter average difference between the skyscraper heights in New York compared to the skyscraper heights in LA. And determine the number of heights. Okay, there's a couple of ways to do this. I can just do the len of this array, so NY heights. And you'll find that there are, what, 73? There we go. I want to point this out. Why are the skyscrapers taller in New York than they are in LA? Well, they're perfectly capable of building tall buildings in LA, but LA is in an earthquake zone, right? So do you really want a lot of big skyscrapers in LA? We saw what happened in 1989 when there was the earthquake that hit San Francisco. And again, with that kind of damage that happens due to earthquakes, do you want skyscrapers? And the answer is probably no. There's fewer skyscrapers in LA. I know it's a smaller city, but it's not. Um, uh, it's still a big city, right? There could be more tall buildings, but I think they're being cautious. And by the way, um, same thing in Florida and places that are affected by hurricanes. It changes the architecture, right? So, like in Florida and South Carolina and coastal Georgia, right? They have hurricane straps, right? They actually strap the heating and air conditioning units on the roof of these buildings, right? Why? Well, just in case there's a hurricane, they don't want, an air conditioner being ripped off the ceiling, and then you have this, very heavy air conditioner that gets thrown into a building or a car where humans, their pets, are being injured or possibly worse. So same thing in LA. There are probably just some restrictions on how tall they'll let them build the buildings because hurricanes hit Florida and earthquakes hit California, and they're gonna have some regulations about, the kind of architecture they're gonna allow. That makes sense. How many skyscrapers in the table are located in Chicago? Well, I can do a sky dot where city is Chicago. I can do dot num underscore rows, which is cool, except, okay, there are 36. Let me just show you this, right? I'm going to hashtag the dot num rows, right? It creates a table. It does the dot where, and the dot where is displaying a table with only Chicago skyscrapers, right? And, there's 26 rows omitted here, so you can see it's got, and we're just going to use the dot num rows, which says how many rows are in the table. Well, there's a row for every building in Chicago that's a skyscraper in this table. So if I count the number of rows in the table, I get 36. Also, I can pull it out, right? I can do sky.where city is Chicago. I can do dot column height, right? And I can do the length of that, len, and put parentheses in. I needed an extra parentheses there. Still not liking this. Um, oh, I didn't close my quotations there. It still isn't liking it, so I add an extra parentheses when what I needed to add was an extra quotation. There we go. It's the same way. So if I have a column, right, I can calculate its length by using the len function. If I have a table, I can use the dot num rows method. All right, so now we have two different ways that we can calculate it, but they only asked for the one, so I'll leave it as dot num rows. Okay, so we have a nice review of some table methods and learning some more about arrays and the connection between the two. I'll see you soon.